Okay, this is our lesson on collecting data. We'll be looking at identifying populations, samples, and telling whether or not they contain bias. We're going to start by watching a few movies, or little video clips.
How do you predict the winner of an election before the election takes place? In this lesson, you will learn how to collect data about a population by identifying a sample of the population. Let's review. Statistical questions are used to gather data about a population. Here's an example. How many texts do middle school students send a day? In this case, the population we're interested in is middle school students, and the data would be how many texts middle school students send each day. Let's get started. The blue figures represent an entire population. For example, the population of middle school students. If we wanted to know a piece of information about this population, for example, how many texts students send each day, we might ask every single student. That could take a long time. Let's consider this population and think of a different way to collect information. By surveying a sample of the group, you can make a generalization about the entire group, also called the population. Let's break it down. The population is the entire group being studied. In this case, the blue figures. A sample is part of the population being surveyed. The green figures, who you can see are responding to the statistical question. We can use their responses to make a generalization about the entire population. This way, we don't have to ask every single member of the population, which would take a long time and be logistically difficult. Let's look at an example. You are asked to predict the winner of the upcoming presidential election. Let's identify the population and the sample. In this case, the population that we're interested in is all American voters, because they will decide the winner of the election. Now, it would take a long time and be logistically difficult to ask every single American voter who they plan to vote for. So instead, we'll ask a subset of American voters called the sample. We could sample adults walking to work. This way, we could use the responses from our survey to make a generalization about all American voters and predict the winner of the election. Let's look at another example. You are asked to track migration patterns of a bird species. It's important to note that a population is not always people, and we don't always ask them a question. Sometimes we gather data in different ways. In this case, we'll identify the population and the sample. The population is an entire bird species. Again, we can't collect data from every single bird in the species. That would take a long time and be logistically difficult. Instead, we'll collect data from a sample. A sample you might use could be tagged birds, birds that have been specially marked so we can track their locations over the course of the year. Then we can use the data on the tagged birds to make a generalization about the migration patterns of an entire bird species. In this lesson, you have learned if you had to order t-shirts for your entire school, what sample would you choose to help you predict how many t-shirts of each size to order? In this lesson, you will learn how to identify representative samples by differentiating between biased and unbiased methods of sampling. Let's review. The population is the entire group being studied, while a sample is part of the population being surveyed. Now be careful. Not all samples will lead to good predictions about an entire population. The blue figures represent a population of 7th graders, and we'd like to gather some information about the height of those 7th graders. If we choose the first 7 students for our sample, we're not going to be able to make a very good prediction about the entire population. In fact, a representative sample is needed in order to make a valid inference. Valid means accurate, and an inference is a prediction based on data. So in order to make an accurate prediction about the entire population, we need a sample that's very representative of that population. The question is, how do you get a representative sample? Well, it's all about your sampling method. There are 2 types of sampling methods. One is unbiased. That means that any member of the population is equally likely to be chosen for the sample. A biased sampling method, on the other hand, means that some members of the population are more likely to be chosen to be in the sample for one reason or another. Let's look at an example. You're in charge of ordering t-shirts for your school for field day. You don't have time to ask everyone his or her size, so you're going to have a sample. You could choose for your sample the football team. Your data might look like this. This sample comes from a biased sampling method. It is not representative of the population. The sampling method is biased because people who were more likely to have large t-shirt sizes were chosen for the sample. So there was a bias in the sample. On the other hand, you could have used for your sample every 4th student entering the school building. This sample comes from an unbiased sampling method. It is representative of the population because every 4th student doesn't have a greater likelihood of wearing a particular size t-shirt. Let's look at another example. We'd like to collect data about the color of leaves in September. We can't mark the color of every single leaf, so we'll use a sample. Let's look at a few samples and decide which is unbiased. 100 fallen leaves collected from the ground. Well, if you only collect leaves from the ground, they're more likely to be brown already. So that is a biased sampling method. Not all leaves are equally represented. Sample B, 100 leaves on tree branches. Well, for the same reasons, this is a biased sampling method as well. Only leaves on tree branches have been collected, and so they won't be representative of the entire population because they're more likely to still be green. Sample C, 50 fallen leaves and 50 leaves on branches. This is an unbiased sampling method because the sample is made up of both fallen leaves and leaves on branches, so it is likely to be representative of the entire population of leaves. Sample D, 50 fallen oak leaves and 50 oak leaves on branches. Well, in this case we have leaves from both the ground and from branches, but only leaves of one species, oak, are collected. And so that is a biased sampling method because not all leaves in the population have an equal likelihood of being in the sample. In this case, only sample C is a sample that is unbiased and will lead us to a valid inference about the color of leaves in September. To review, an unbiased sampling method will lead you to a representative sample, which you can then use to make a valid inference about the entire population. In this lesson,
what would be a representative sample for predicting which candidate is leading in the mayoral election? In this lesson, you will learn how to generate a representative sample by identifying types of random samples. Let's review. An unbiased sampling method is one in which any member of the population is equally likely to be chosen for the sample as any other member. When we have an unbiased sampling method, we are most likely to end up with a representative sample. And that representative sample enables us to make valid inferences about the population. But it all begins with that unbiased sampling method. Now, be careful. You might think members of a representative sample are carefully selected to represent the population. But you have to remember that we don't know what the whole population looks like. That's why we need a sample in the first place. So the sample can't be hand-picked to be representative. Instead, we have to use a sampling method that is most likely to give us a representative sample. Let's look at a student breakfast survey, where students were asked what they ate for breakfast each day of the week. There are three main types of unbiased sampling methods that can be used for this type of survey: a simple random sample, a systematic random sample, and a stratified random sample. Let's take them one at a time. A simple random sample is when names are picked at total random, for example, out of a hat. This can also be done by computer. A systematic random sample is when the sample is chosen randomly, but there's some system to it. For example, every sixth student might be surveyed. That would be a systematic random sample because there was some order to it. The third type is the stratified random sample. Of the whole population of girls and boys in the school, the sample could include 25 boys and 25 girls. This sampling method first breaks the population into groups, like boys and girls, and then chooses a certain number at random from each group. The important thing to remember is that unbiased samples must be random. You saw that the three types of representative samples are simple random sample, stratified random sample, and systematic random sample. It's no coincidence that they all have the word random. In order to have the greatest likelihood of creating a representative sample, we need to have the sample randomly chosen. In this lesson, how do you generate a sample of the population that isn't biased? In this lesson, you will learn how to generate a representative sample by identifying types of biased samples, and then avoiding them. Remember, an unbiased sampling method, which usually contains some element of randomness, is most likely to lead you to a representative sample. That representative sample will then enable you to make a valid inference about the entire population. But it all begins with that unbiased sampling method. Often, students think that biased sampling methods are obvious and easy to avoid, but that's not always the case. If you were asked to estimate the average t-shirt size of students in your school, you could choose for your sample, say, the football team. Well, that's a biased sampling method. The students on the football team are more likely to have large t-shirt size than the average student. So you're not likely to have a representative sample. That was an obvious one, but they're not always so easy to avoid. We'll look at some examples now. Let's look at a student homework survey and check out some biased sampling methods that might lead you to have an unrepresentative sample. The two main types of biased sampling methods are convenience samples and voluntary response samples. Let's take them one at a time. The first type of biased sampling method is a convenience sample. Well, a convenience sample is called that because it's convenient or easy. Looking at this population of students, we could choose the first 5 students as our sample. They were the first 5 students to walk into school, so it's nice and easy and convenient for us to ask them our survey question, have them all in one place to collect our data, and be done. Now, there might not be an obvious reason why this would lead to biased results, but there might be underlying facts that you're not aware of that could affect this sample. For example, maybe the first students to arrive to school in the morning are the most well prepared, and so they spend many hours on their homework each night. Or it could be that the first 5 students to come to school are all a group of friends, that's why they came together, and friends are likely to have similar homework habits, but not necessarily representative of the entire school. That's how a convenient sample can lead to biased results. Another type of biased sampling method is a voluntary response sample. A voluntary response sample is when members of the population volunteer to participate. Not everyone needs to respond, but there might be some reason that those who choose to respond have done so. For example, in the homework survey, students who spent many hours on their homework might want to respond so that they can share the many, many hours that they spent. You might, on the other hand, have a student who wants to share that they spent very few hours on their homework. Either way, you won't have data that's representative of the population because those members who volunteered had some reason to do so based on their response. Let's look at an example of a biased sampling method in a real-life survey. How many miles do Americans drive each day? Well, we can't ask every single American, so we'll collect data from a sample. Let's look at 2 sampling methods. The first is conducting a survey at a senior citizen center, and the second is preparing a hotline number for drivers to call and report the number of miles they drive each day. Let's take the first one. The survey at the Senior Citizen Center would be very easy for us to do. We would just have to go to one place, ask everyone the same question, record our data, and we'd be finished. That makes it a convenient sample. It's easy to collect the data for. However, it's also biased because it's convenient. All the people at the Senior Citizen Center may be more likely than other Americans to drive less, and so our data from the sample might not be representative of all Americans' driving habits. The second example, having a hotline for drivers to call, is a voluntary response sample because only people who choose to call in will be part of the sample. You may end up with many people who drive many, many miles each day and are excited to call in and brag about their high level of driving. Or you could have people who are proud that they never drive at all. Maybe they ride their bike or walk. And so they might call in. This isn't necessarily representative of the population, though. It's more indicative of a group of people who have some reason to call in based on their response. Neither of these samples will lead you to a representative sample because they both come from biased sampling methods. In this lesson, you have learned how to generate a...
Okay, so we just learned about all the different types of sampling methods, and we want to be able to identify here some of the random samples and the biased samples. So if you look at the first 3, let me get a color here that'll work. The random, systematic, and stratified. Remember, those 3 are examples of random sampling, and they would lead you to the best representative sample. Okay, and that's our goal, is to get a representative sample of the population. The last 2 are examples of sampling that will give us a little bit of bias. It might not be totally representative of the whole group. So we will call that a biased form. Okay, and in the next few examples, we're going to be taking a look at identifying populations and talking about whether or not the sampling is biased. So example 1. For each survey, describe the populations and then tell whether each sample is random or biased, and let's explain our reasoning. If a politician asks people to volunteer to be interviewed on their opinion of some policy issues, the population would basically be all the people in the politician's district, and because the sample is self-selected, it would contain bias, because it'll be only the people who volunteer, probably the most highly opinionated people, and not necessarily representative of the whole population. A computer is used to randomly choose 50 student identification numbers from the entire set of student members at your school in order to choose who to question regarding the amount of time they spend on homework, kind of like that last video. The population would be all of the students at your school, and this would be a very random sample and representative of the entire student body because it is randomly selected. And finally, college students are grouped according to major, and then some from each group are selected to fill out a survey on their opinions of how a donation to the cafeteria should be spent. So the population would be all the students at the college, and then because it is a stratified sample where they are divided into groups, it is part of the random sampling method, and it would be representative of the entire group. So you would have all different majors, participating, business, art. Everybody would have an equal say. In example 2, we have a company that's researching new product ideas and wants to get feedback from potential customers. The possible new products are a new movie, a new book, or a new video game. We're going to tell, looking at these next survey methods, whether they would contain bias in their sampling. So the company's going to install pop-up surveys on the internet to be activated on book sale websites. This method could result in a biased sample because people visiting book sale websites may favor the new book as the new product. In addition, the surveys neglect the part of the population that does not have internet access. Therefore, it would not be representative of the entire population. They could also survey people as they exit a restaurant. This method is less likely to be biased because a wider range of people will be surveyed. However, this method is not truly random because it's like a convenience sample. It's one of those biased samples. People not at the restaurant have no chance of being selected. Also, the people at the restaurant are not necessarily the potential customers, so as a result, the sample may be biased. In example 3, we are going to tell whether the question is potentially biased. We're going to explain our answer. If the question is biased, we want to rewrite it so that it is not. So here's the first one. Would you rather play an exciting, fast-paced game of tennis or compete in a disappointing and frustrating game of golf? Yep, you guessed it, it contains bias. It suggests that tennis is superior to golf. An unbiased question is, would you rather play tennis or golf? So basically, leave the adjectives out of it in order to sway the answer to the question. So we want to keep it as unbiased as possible. Let's try another. How do you feel about the inhibiting new city ordinance? Yep, it's biased. It suggests that the new city ordinance restricts people's freedoms because they use the word inhibiting. An unbiased question is, how do you feel about the new city ordinance? Can you tell a difference? In these next exercises, we're going to use the following information. Every fifth fan arriving at a high school basketball game is asked, do you agree with the school board's decision to implement a block schedule? Let's tell whether the survey method could result in a biased sample. and then explain your reasoning. It could result in a biased sample because people not attending the basketball game have no chance of being selected. Again, this is one of those convenience methods. Only people at the game are being asked. And the school board's decision would apply to the entire population, which would be basically all the members in that school's district, right? All of the community members involved with the school and paying taxes to the school and everything else. So the question again, do you agree with the school board's decision to implement a block schedule? Is the question potentially biased? Explain your answer. If the question is biased, rewrite it so that it is not. Actually, it's not potentially biased. It does not indicate the advantages or the disadvantages of block scheduling.